Okay, guys, so today we are going to have our notes. This is our first video notes with our hybrid schedule that we have. So you guys are going to copy down these notes. You can either watch the video and write along with me using the teacher guided notes that I attached, or you can write your own as long as they look like the notes that I have. And then you're going to upload them to the classroom. That'll be your attendance for today, so that I know that you've hopped on here and you've taken your notes. And that way you'll be prepared for our in-class learning when we come back next week. So today's notes are on graphing linear equations. And I know you guys may have seen this if you got to some of the review questions from our first week back. You may have seen there were some questions where a graph was given and you had to find the equation. So we're going to look at that a little bit more here today. So when we're graphing linear equations, I know I told you that y equals mx plus b is the slope-intercept form for a linear equation. And there's different forms that it can be written in, but the slope-intercept form is a really great form when you're graphing because it tells you the two most important things you need to know when graphing, which is your y-intercept and your slope, hence the name slope-intercept form. You can literally see them. So the b, which is your y-intercept, tells you where to begin. I always like to think b for begin. And the m is your slope. And remember, our slope is always rise over run. It tells us how we move. So the order that you're going to follow when you're graphing from an equation would be to start at the b value on the y-axis. Remember, your y-axis runs vertically up and down. Then you're going to move from that b value that you just plotted. You're going to move based on your slope. So whatever your slope is, that's how you move. It tells you how much to go up and how much to go over. If your slope is not a fraction, just put it over 1. So if you don't have that bottom number, make it a 1. Remember, the y-axis is the rise, so it tells you whether or not you go up or down. The x-axis is the run, tells you whether you go left or right. So our first equation. These three equations are given to us in slope-intercept form. We're going to pull the two important pieces of information that we need from this equation. That way we can graph it. So here we go. The b, I always start with the b because it makes me think of begin, so that's where I'm going to begin. The b value, or the y-intercept, is the positive 3 that's at the end. So we just write 3. The slope is that m value, which in this case is a 2. If I want to write it down like a fraction, so when I'm looking at it, I can see the rise over run, I'm going to write it like 2 over 1, so that I know I go up 2 and to the right 1. Remember, this is a positive 2, so both of these are positive numbers. So I'm going to go up 2 and to the right 1, because on the x-axis, moving to the right is positive and moving to the left is negative. On the y-axis, moving up is positive and moving down is negative. So that way you know which way to go. So over here on the graph, we're going to put our y-intercept on 3. That's where we begin. 1, 2, 3. So we put a dot right there. It needs to be on the y-axis. That's why it's the y-intercept. So it should be on the line. From here, I'm going to move up 2, 1, 2, and over 1, 1. From this new dot, I'm going to do the same thing. Up 2, over 1. Same thing from this dot. Up 2, over 1. Up 2, over 1. And you can do the reverse of that. I can go down 2 and to the left 1, because we know in math 2 negatives is a positive. Down 2 and to the left 1. So if I'm doing negative and negative, it'll still be positive in general. And then just get you a straight edge somehow. Just going to use this note card that I have some math stuff written on. And I will connect my dots. Always put an arrow at the end. Sorry about that. Always put an arrow at the end to let you know that this line continues going even off this graph. It isn't stopped, because if it's stopped, that would just be a certain interval of the line. So we want to show that this line keeps going. So let's move on to the next one. Our next one is y equals negative 1/2 x plus 4. So again, I'm going to start with my b value, which is my y-intercept, which it looks like is positive 4. So I'm going to put positive 4. My slope, or my m value, is negative 1/2. Okay, so now that I've pulled those two pieces of information out of my equation, I'm going to move to the graph. I'm going to start at the b value. That tells me where to begin. So if it's a positive 4, I'm going to start at the positive 4 on the y-axis. Now my slope is negative. Notice there's one negative sign, and then there's my fraction. That does not mean that it is -1 and -2. So I'm not going to go down 1 and to the left 2, because two negatives actually makes a positive. Only one of these values is negative, and you can choose, and I'll show you, it doesn't matter. So if I want my 1 to be positive, that's my rise, and my 2 to be negative, that's my run, then I would go up 1, because I want my rise to be positive, and to the left 2, because we know moving left on the x-axis is negative. So my rise can be a positive 1 as long as my run is a -2. Or I can flip it and make the top number negative. My rise can be negative and my run can be positive. So I could go down 1 and make my rise actually negative, go down 1, and make my run positive to the right 2. Down 1 and to the right 2. As you can see, these points are all falling on the same line. I'm either going up and to the left, and the left part is my negative, or I'm going down and to the right, and the down part is my negative. Either way, one is negative and one is positive. Don't make them both negative. When you connect these dots, you'll notice that the slope of this line is a negative slope, because if you look in the equation, we have a negative slope. Connect your dots, put your arrows on the end, and that's your graph. It's super easy once you know the two things to look for in the equation. And then the last one, my b value is where I'm going to start. So in this equation, my b value is -3. And my slope, sorry about that lighting. My slope, it doesn't look like I have any number here. But we know that that doesn't mean it's a zero slope, because 0 as a number right here, well, 0 times anything would be 0. And so that can't be, because that would make this x completely disappear. So the imaginary number that we can't see but we know is there is 1, right? Because 1 times whatever this x may be won't change this x at all. This x can still be here. So if there's not a number in front of your x, your slope is 1. It's always 1. We just don't usually write 1 because anything times 1 or anything divided by 1, it doesn't really change the number. So let's write it as a fraction so that when we look at this, we can see our rise and we can see our run. So again, to make anything a fraction, you put it over 1. So I'll just turn this into a fraction. So we're going to come over to our graph and we're going to start at our y-intercept, which is now -3. So I'm going to go down the y-axis to -3 and put a dot. From this y-intercept, I'm going to move based on my slope, and this looks like a positive 1 in both areas. So I'm going to rise 1 and run 1. So rise 1, and a positive on the x-axis is running to the right. Put a dot. So I'm just going to keep going up 1, over 1, up 1, over 1, up 1, over 1, over and over and over. Like that. And there's your linear equation. Now let's move on to the back page real quick. We have 2 more problems. And these problems are special problems because they're not in slope-intercept form, which makes our life a little bit more difficult. So if you're asked to graph a linear equation and it's not in slope-intercept form, just rearrange it. So we know, if I flip back, this is the slope-intercept form that we like when we're graphing because we can physically see our intercept and our slope, which tells us where to start and how to move. If it's not in that form, and this is standard form, you have notes on that right here, page before. If it's in standard form, just rearrange it. You need to get y by itself. So anything on this side with y needs to go over here. So remember, we always add or subtract first. So since this 2x is being added to this 3 times y, I'm going to subtract the 2x. I'm going to do the same to the other side. You have to keep your equation balanced. The equal sign is the middle, so what happens on this side has to happen on this side. Those actually cancel, leaving you with 3y equals, right? So we bring down what's left, we bring down our equal sign. When we rewrite this, let's go ahead and put the coefficient with x first, since we know we want mx plus b to be the form that we're getting to. So when I choose to rewrite this, instead of doing 6 minus 2x, I do negative 2x and positive 6. I want it in this order because if we look at this equation, that anything with the x stuck to it comes first, and that's how we know it's the slope. So if we have the option to write it in whatever order we want on this side, let's go ahead and do that. We have one last step to get y by itself, and if that y is being multiplied by 3, to undo that, we divide by 3. And again, what you do to one side, you have to do to everything on the other side. So now our final answer is y equals negative 2/3 x plus 2, right? This fraction can't simplify anymore, so that's just what it is. This fraction can, so we simplify it. But it's okay if you end up with a fraction connected to your x because it makes your life easier when you go to graph, because we know rise over run is a fraction. So I'm going to look for my m and my b. Well, I can see it much clearer now. My b value is a positive 2. My slope is negative 2/3. And again, it doesn't matter which one gets that negative symbol as long as only one is negative. So I'm going to start at 2, and I'm going to go up 2, left 3. Up 2, left 3. Up 2, left 3. So I chose my run to be negative. So I was moving in the negative direction on my x-axis. I'm going to do the same thing on the other side, but this time I'm going to make my rise negative, and I'm actually going to go down. So I'm going to fall 2, run 3. Fall 2, run 3, 2, 3. And I'm going to connect them. And I have now graphed this equation, but I rearranged it so it was easier for me to read. The very last one, we have negative 3x plus 4y equals negative 8. So again, I need it in y equals mx form, which means this y needs to be completely by itself. So on this side of the equation with the y, I have minus 3x and times positive 4. So I need to undo those. So to undo this minus 3x, I'm going to add 3x. Remember, we always do addition or subtraction first. That cancels. So I'm left with 4y equals, and when I rewrite these two, I'm going to choose to put the 3x first. And then the very last thing I have to do is to divide this 4 away because it's multiplying to that y. So we have y equals 3/4x minus 2. That reduces down to 2. So when I write down what my slope and y-intercept are, the b value is negative 2. The slope is 3/4. That tells me how to move and where to start. So I'm going to start at negative 2 on my y-axis. And I'm going to rise 3, run 4. Rise 3, run 4. And I'll do the same thing going down. I can go down 3 and to the left 4 because I know 2 negatives make a positive. So once you connect your dots, you'll see your straight line. And again, when you're graphing linear equations, they will always be completely straight because from one point to the next, to the next, to the next, your slope is the same, or the way that you move is always the same. So if you're graphing your points and you're getting weird shapes like a U or a V, or even some crazy swirls like a C or an S, that's not a linear equation and you've graphed it wrong. So make sure you get these copied down, and I will talk to you guys tomorrow for tomorrow's notes.